Hello students, welcome back to Sleepy Series. Tonight, we slowly revise. Working stress method, neutral axis, singly reinforced beams, and important beam concepts. Relax your mind, no pressure, no stress, just calm revision. Listen slowly and let the concepts settle naturally into memory. Working stress method, also called elastic method, is one of the oldest design methods used in RCC design. This method is based on Hooke's law. Stress is proportional to strain within elastic limit. In working stress method, materials are designed under service loads and stresses are kept within permissible limits. Factor of safety is applied on material strength to obtain permissible stress. Factor of safety for concrete in bending compression is nearly 3. Factor of safety for steel is nearly 1.78. Working stress method gives safe design, but comparatively uneconomical sections because higher factors of safety are used. Now assumptions of working stress method. Plane sections before bending remain plane after bending. Perfect bond exists between steel and concrete. Steel and concrete behave elastically within working stress range. Concrete carries compression, steel carries tension. Concrete in tension is neglected in cracked section analysis. Now modular ratio. Modular ratio means ratio of modulus of elasticity of steel to modulus of elasticity of concrete. Formula M equals ES divided by EC. According to IS code, modular ratio equals 280 divided by 3 sigma CBC. Higher modular ratio means lower grade concrete, because modulus of elasticity of concrete decreases. Now transformed section. Steel and concrete have different elastic properties. To simplify analysis, steel area is converted into equivalent concrete area. Equivalent concrete area equals meters multiplied by steel area. This converted section is called transformed section. Now neutral axis. Neutral axis is the axis where bending stress becomes 0. Above neutral axis, compression develops. Below neutral axis, tension develops. Position of neutral axis depends upon amount of reinforcement, modular ratio, and beam dimensions. Stress distribution in beam is linear. Maximum compression occurs at top fiber. Maximum tension occurs at bottom fiber. Now, singly reinforced beam. A singly reinforced beam contains reinforcement only in tension zone. Concrete resists compression. Steel resists tension. These beams are economical and most commonly used in buildings, bridges, and slabs. Effective depth is the distance from compression face to centroid of tension reinforcement. Greater effective depth increases moment carrying capacity. Now types of sections: under reinforced section, balanced section, and over reinforced section. Under reinforced section contains lesser steel than balanced section. Steel reaches yield stress first before concrete crushes. Failure is ductile, safe, and preferred. Large cracks and deflection develop before collapse. This warning before failure makes under reinforced sections safer. Now over reinforced section. Over reinforced section contains more steel than balanced section. Concrete crushes first before steel yields. Failure becomes sudden, brittle, and dangerous. No sufficient warning is available before collapse. That is why over-reinforced sections are avoided in practice. Balanced section means steel and concrete reach permissible stresses simultaneously. Balanced section is mainly theoretical because practical design prefers under-reinforced behavior. Now lever arm. Lever arm is the distance between compressive force and tensile force. Formula: Z equals D minus X by 3, where D is effective depth and X is depth of neutral axis. Greater lever arm means higher moment resistance. Now moment of resistance. Moment of resistance means bending resisting capacity of beam. Formula: MR equals sigma ST AST multiplied by D minus X by 3, where sigma ST is permissible tensile stress in steel and AST is area of tension reinforcement. Moment of resistance depends upon steel area, effective depth, and permissible stresses. Now cracking in beams. Concrete is weak in tension, therefore cracks develop in tension zone. Fine cracks are acceptable within permissible limits, but excessive cracks reduce durability and allow corrosion. Proper reinforcement spacing, proper cover, and proper detailing help in crack control. Now deflection. Deflection means vertical displacement of beam, underloading. Excessive deflection creates serviceability problems. Deflection depends upon span, load, moment of inertia, and modulus of elasticity. Long span beams show greater deflection. Creep also increases. Long-term deflection. Span to depth ratio helps in deflection control. For simply supported beams, basic span to effective depth ratio is 20. For continuous beams, 26. For cantilever beams, 7. Now bond stress. Bond between steel and concrete is extremely important. Without proper bond, steel slips inside concrete and load transfer fails. Deformed bars improve bond strength because ribs increase friction. Hooks and bends also improve anchorage. Standard hooks generally use 180-degree bend. Now permissible stresses. Permissible stresses are obtained by dividing ultimate stresses with factor of safety. Permissible compressive stress in concrete depends upon concrete grade. Permissible tensile stress in steel depends upon steel grade. HYSD bars allow higher permissible stress than mild steel bars. Now doubly reinforced beam. Sometimes beam depth is restricted or moment reversal occurs. Then steel reinforcement is provided both in compression zone and tension zone. Such beam is called doubly reinforced beam. Doubly reinforced beams provide greater stiffness, better ductility, and higher moment capacity. Now limitations of working stress method. Concrete actually behaves non-linearly, but working stress method assumes linear elastic behavior. Ultimate load capacity is not directly considered, and design becomes less economical. Therefore, modern RCC design mostly uses limit state method. Now, rapid revision. Working stress method is elastic method. Plane sections remain plane after bending. Concrete carries compression. Steel carries tension. Modular ratio M equals ES divided by EC. Lever arm formula Z equals D minus X by 3. Moment of resistance MR equals sigma ST AST multiplied by D minus X by 3. Under reinforced section is ductile and preferred. Over reinforced section is brittle and unsafe. Neutral axis is axis of zero stress. Greater effective depth increases beam strength. Deflection is serviceability criteria. bond between steel and concrete is essential for load transfer. Good night, students. Relax your mind and let the concepts revise automatically. Sleep peacefully.